Good day, everybody. Today we're going to look at apportionment using Webster's method, and that's where you divide and then just round regular. So let's see. This is the 2010 apportionment population for the country. And, well, to get the standard quota, you could look at the fraction of each state's population to the total U.S. population, multiply that by 435 to get the fair amount of the 435 each state should get, or equivalently, if you divide 435, number of seats, into the total population, you get that there should be 710,767 people for each seat on average. And then divide that people per seat average into the number of people for each state. Again, you get the standard quota. And well, if you round the standard quota, you generally can't expect to get exactly 435. In this case, we're short by 2. So if we were to look at Hamilton's method, we see that after regular rounding, there's 2 more seats still to give. The next 2 seats, the next 2 states to get a seat would be Rhode Island and then Minnesota, in that order. But let's do it with Webster's method. So if we go back over here, we're going to change the divisor. So we need to make it smaller. So you may be above 435 or you may be below. If we're below, I need to make this smaller. So if I divide by a smaller number, then all the fractions get bigger. And if I do that, I looked ahead of time, so 708,000 works as a divisor. And now regular rounding with dividing each state's population by that number gives the apportionment. So notice the 2 states that gained a seat were not Minnesota, although Minnesota did gain, but it wasn't Rhode Island, which was actually ahead of Minnesota on Hamilton's method. But Rhode Island did not get the seat. Instead, it was, well, I forget, let me check here, North Carolina. So North Carolina, right there. So North Carolina moved up. And what's basically going to happen is, if you're dividing by a smaller number, bigger states will be better off. So if I look at the comparison for 2010, Webster and Hamilton agree, except with Webster, Rhode Island would have gotten a seat and not North Carolina. But with Webster, North Carolina got the seat and not Rhode Island. Look at another year, say 2000. Again, if I use, oops, so this will be the value that works. Well, we won't do it. So if you do regular rounding, you come up 433 again. So I have to divide by a smaller number. 645 actually worked here. And now we're at the 435, thanks to me dividing by a smaller number. If I were to look at Hamilton, again, regular rounding was too short, and then Hamilton would have given, again, North Carolina, and Utah, well, not again, Webster gave North Carolina last time, but so it'd be North Carolina and Utah would have gotten the seats in 2000. But it'll be a little bit different with Webster. Instead of North Carolina and Utah, it's California and Utah. So California benefited. So again, California would not have gotten the seat with Hamilton. but it did get it instead of Utah. Let's look. So this shows the apportionments there, and so again, instead of Utah, it's California getting the seat. One more to look at. 1990, now regular rounding gives us too many. So, I mean, that can happen as well. So regular rounding, you could have too much or too few. If we look at Hamilton, again, you can see these three fractional parts are all above 0.5. So if you use regular rounding, at least with the standard divisor, you're going to get too many. So Hamilton would stop before these three states got it. So New York, Mississippi, and Oklahoma. But let's see if I change the divisor to get regular rounding to work. I now have to have a bigger divisor, and this one's pretty fine. So let's see, 574, 150. So it took a lot of experimenting, and I went to a lot of decimal places here so you can see how close it was. So Massachusetts barely got the seat. Mississippi got the seat instead of New Jersey and Oklahoma, and they were ahead of Mississippi, at least using Webster's method. So that 0.518 leaped ahead of the 0.536 and the well, actually that one's still below, so 0.518. So again, who got it? Mississippi got it instead of New Jersey. If we were to use Webster as opposed to Hamilton. And the final comparison right there. So ignore these changes. So the changes were Mississippi got the seat instead of New Jersey. In 2020, regular rounding actually worked. So if regular rounding works, then definitely Webster's and Hamilton agree. Now, since Webster is a divisor, we call that a divisor method, where you just pick a divisor and then use rounding to get the apportionment. You won't have the paradoxes, the new states paradox, the population paradox, or the Alabama paradox. So these paradoxes that happen with Hamilton's method won't happen with divisor methods, but instead all divisor methods are susceptible to quota violations, and generally things have to be pretty extreme for Webster's method to have a quota violation. But if I look at this hypothetical country of these four states, if these are the populations, sometimes D has a significant portion of the entire population. So this would be the standard divisor, this would be the standard quota right here in this column. And so with Hamilton's method, you would round state D down, it would get its lower quota. Everybody would get their lower quota, and then that would mean you would still need 2 more seats, I think. So the next two states to get a seat would be B and C. So they would go up to 3 and 5. So this would be the apportionment with Hamilton's method. But with Webster, if you divide, then because at this point, regular rounding gives you too much, right? So all 3 states would round up. So you need to find a divisor that's bigger than the standard divisor. That's going to affect the bigger state more, and in the end, with this divisor, if you divide that amount into these populations, this is the new fractional amount. And of course it's pretty close, but D rounds down to 25, and then these three states round up. But if you look at the standard quota, state D should get either 26 or 27. Seems the fair amount. To go below 26 is considered a quota violation. And then the same thing can happen in the other direction. Here's two examples where now regular rounding is too little. So I need to have a smaller divisor, and that affects the bigger state more. And so state D seems fair to give it 24, but using Webster's method it would get 25. Similar over here, state D seemed fair to give it 23, but with Webster's method, when you do the division, it affects this big state more, and in the end it gets the 24. But again, these are sort of contrived examples. I don't think it'll ever happen with the population of the 50 states. So that's Webster's method, a divisor method. There is another way to do all divisor methods. There is another way to get the apportionment called using a priority. We'll look at that in a bit. And we'll also see what properties that Webster optimizes, what desirable properties. So all these methods have certain properties that are desirable, and of course it turns out the different methods will optimize different properties, so you can't have it all. But we'll look into that later as well.